Today we are on 1.2, and this is a review of factoring. So there are a couple different types of factoring. The first one deals with greatest common factor. So if I had 4x to the third, let's not do 4. Let's do 6x to the third plus 12x squared minus 9x. What is the greatest common factor of those three terms? 3x. So I can sort of reach in and yank out a 3x from all of them. And if I did that, what would be left? 2x squared, 4x minus 3. Okay. Anybody need a refresher on that? We're good? Okay. You want another one? Okay. So let's say I had what is the biggest common factor, the greatest common factor among all of those? 6. And then how many x's? 3. And then y squared. And then you just divide that out from everything else. So 12 divided by 6 is 2. I bring out a triple x and a y. Does that make sense? Okay, and then 4x, and the y's both come out, and then plus 5y to the third. Good? Oh, thanks. Do I pass? All right. The next type is factoring quadratics. Now, I want you guys to factor using the box, so I'm going to show it to you. Some of the problems you can do without the box, but some of the problems you need it. So let's say I had x minus 4 and x plus 7, and I was going to multiply them together. One way to do it is to do this. We set up a grid that's 2 by 2, and I put, x minus 4 and x plus 7. Okay. Then I multiply things out. X times x is x squared. X times negative 4 is negative 4x. 7 times x is 7x. And 7 times negative 4 is negative 28. Okay. Now we combine like terms. These go together. And I'm left with x squared plus 3x minus 28. Okay. Now, how can we deconstruct that? How can we go backwards, starting with x squared plus 3x minus 28? So, write this down. Yes, that's the question we're going to be asking. So, to start this, and again, you might be able to do this in your head, but I want you to write this down because for the more difficult problems, this is way easier to do it this way. So x squared is going to go in the first box, and negative 28 is going to go in the last box. Everybody follow? Now, I multiply those together, and I get negative 28x squared. And I'm going to write down all of the factor pairs for 28. So 1 and 28, 2 and 14, 3 does not work, 4 and 7, 5 and 6 don't work, and 7 is already listed, so I don't need to list it twice. All right? Now, are there two numbers in that list that multiply to create negative 28 an add to create positive 3x. It's 4 and 7, but it's actually negative 4 and 7. How do I know that one of them needs to be negative? The 28 is negative. The only way to multiply two numbers together and result with a negative is if one of the original two is negative and the other is a positive. Okay? What if that 28 was positive? Then they would either both be positive or both negative. Okay? And it just so happens that the end result when these two numbers fight it out is positive 3. So the bigger of the two numbers has to be positive. Because when the 7 and the 4 fight, the 7 is going to win, and the end result was positive 3, which means that the 7 has to be positive. And don't forget, negative 4 times 7 is not 3x. Sorry, negative 4 plus 7 is not 3x. It's actually negative 4x and 7x. So I put those in either of these two boxes. It doesn't really matter. Negative 4x and 7x. And then we look at the top row. What does the top row share? What's the greatest common factor? X. And then if I yank out an x from both of them, I'm left with x minus 4. You guys see that? And then I take the x out of this, and I get plus 7. So all I did was undo the multiplication. And my factors are x minus 4 and x plus 7. The 28 helped us build the 4 and the 7. Okay? Yeah, magic. It was a magic trick. Okay, does that make sense? Okay, let's try one. Let's try one on your paper. Let's do. So I'll work it on the board slowly, and you guys work it in your paper, and we'll see if we get the same result. So if you get stuck, go ahead and watch what I'm doing. I've never had better handwriting in my life. Yes. Oh, great question. Why are the 4 and 5 negative? Because I need to create a negative 9. Yes. So the second number is a multiplication solution, and the middle number is the sum. So you're adding them together, and the only way to get a negative 9 is if 4 and 5 are both negative. Okay? That's true. That's a problem. All right, what about this? Oh, not 2. Oh, that's not going to work. Sorry. What was I thinking? So 2, 6, 8, 48, 90. You guys are really helping. Thanks. um, okay. What should I do here? Pull out the 3. Yank out a 3. And I get 3 times x squared plus 2x minus 15. Do I need the 3? It depends on what you're doing. Okay? We'll talk more about that in just a second. So now I draw the box. X squared and negative 15. Negative 15x squared. My options are 1 and 15 or 3 and 5. And 3 and 5 will work if the 3 is negative. Katie, you get that? So 5x and negative 3x. So I pull out an x and I get x plus 5 and then minus 3. So my factors are, oops, let me write it over here. 3 times x plus 5 times x minus 3. So, do I need the 3? And the answer is sometimes you don't. If you are factoring, that 3 is a factor of the original equation. If you're graphing, that 3 is essential in creating the correct graph. If you are solving, meaning trying to figure out what x equals, which is essentially the same thing as saying where does the graph touch the x-axis, that 3 is irrelevant. So the original equation, oh, by the way, if I asked you to find the roots, what would they be? So we write equals 0 on both of those, subtract 5, and add 3. Those are your roots, which means the original equation looks something like, well, that was pretty bad. There we go. Looks something like that. What happens when I remove the 3? No, what happens when I get rid of this? What does that do to the graph? It does change the graph. It makes it 3 times shorter. So it looks like this. But the roots are the same. So if all you care about are the x-intercepts, that 3 is not needed. In all other instances, that 3 is essential. If you're solving, you can ditch the 3. If you're graphing or evaluating or doing anything else, you need that 3. Okay? All right, let's take a look at your assignment for a second. All right, greatest common factor, that's easy enough. Greatest common factor. Okay, so number 8. Ooh, let's do number 7. You can just watch this. So I draw the box, z squared and 12, 12z squared. Are there factors of 12 that add to be 13? 1 and 12. So z and 12z. And that gives me z and z plus 1 and z plus 12. Now, you might be able to do these in your head. If you can do these simple ones in your head, great. You don't need to draw the box. Okay? But when they get more difficult, the box really comes in handy. So, for instance, this one, x squared and negative 12y squared, which is negative 12x squared y squared. And I'm trying to create an 11. So negative 12xy and 1xy. Do you guys see that? So negative 12xy and just xy. What do these share? X. So x minus 12y. And then I pull an x out and I get y. So my factors will be x minus 12y and x plus y. Okay? You can watch the video. Okay. Let's see if any of the harder ones are in here. I don't remember. All right, what are you going to do? What are you going to do with this one? Pull out a 4. Do you need the 4? What do the instructions say? Factor. Yes, you need the 4. Okay? All right, but number 15 is a little bit harder. It's the same process. It's just a little bit more complicated. So, can I pull out a 7? Well, I can, but it's going to create fractions, so I don't want to pull out a 7. Yeah. So instead, I draw the box, and I put in 7, that's not a 7, 7z squared and negative 2, and here's where the box really comes in handy. You multiply those together, and I get negative 14z squared. Well, the factors of that are 1 and 14, or 2 and 7. Can I create a negative 5 from those factors? Yeah. A positive 2z and a negative 7z. Okay. So I put that in here. And then what does the top row share? 7, oh my goodness, 7z. And if I pull out a 7z, I get z minus 1. And then if I pull a z out of this, I get plus 2. And my factors are 7z plus 2 and z minus 1. And that is so much easier than the way I learned that when I was in high school. We guessed. So this one wouldn't be too hard, but on the left you have 1 and 7, and on the right you have 2, 1, and 2. And then you just guess, like you multiply those together and add them and see if you get that. No, it didn't work. So you have to change, you have to do this one, and then you can get a 5. Well, the problem is, if this is a 12 and this is a 24, then we have 1 and 12, 2 and 6, 3 and 4. And over here we have all the same ones, and 4 and 6. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. And you just, I don't know, we'll try this one and that one. And you have to do 3 and 4 and 4 and 12. If that doesn't work, then you flip them, and it's a huge mess. So some of you learned a different way last year. Anyway, if you know another way to factor these, great. But I think the box method is so easy. You don't have to do any guessing. Okay, I think that's everything, but let's take a look and maybe solve one more. Oh, okay, so what if I wanted to know the roots of this? Yeah, so what is the root here? Z equals 1, and then for that one I write equals 0, subtract 2, and divide by 7 would be negative 2 over 7. And just a fun fact, if this number cannot be pulled out, then one or both of your answers will be a fraction. Okay? If you can pull the 9 out, then your answer will be an integer. But if the 9 does not come out, then one or both of the factors will be a fraction. So if you ended up with something like 3x minus 2 and 5x plus 7, so in that case the first number would be 15, and you just end up with fractions on both sides. So do you want to see another one of those? Do you want to give that a try? No? You're good? Okay. Get to work.